Looking at section 2.1, complex numbers. We're going to add and subtract complex numbers, multiply complex numbers, divide complex numbers. We're going to perform operations with square roots of negative numbers and solve quadratic equations with complex imaginary solutions. So getting into the world of the imaginary number. So complex numbers and imaginary numbers. It says the imaginary unit I is defined as I is equal to the square root of -1, where I squared is equal to -1. The set of all numbers in the form a plus bi, where real numbers a and b, and I, the imaginary unit, is called the set of complex numbers. The standard form of a complex number is a plus bi. It's always the real component added with the imaginary unit. So operations on complex numbers, it says the form of a complex number a plus bi is like the binomial a plus bx. To add, subtract, and multiply complex numbers, we use the same methods that we use for binomials. So let's try a couple quick examples. Perform the indicated operation, write the result in standard form. So this gives us a 5 minus 2i that's added with a 3 plus 3i. Since it's an addition problem, we can just go ahead and add the like terms. We don't have to worry about the parentheses. So if I have a 5 and I'm adding that with 3, we're going to end up with 8. If I have a minus 2i and a positive 3i, when I add them together, it's just going to give us a positive 1i. So we could just write it as an I. On part B, however, we have a subtraction. That means we need to pay attention to those parentheses in terms of distributing out that subtraction sign. So if we have a 2 and we are going to take away 12, we're going to end up with a -10. If I have a positive 6i and I'm subtracting a negative, that means that I'm really adding I. So a positive 6i with a positive 1i, that's going to give us a positive 7i, just like binomials. What about multiplying? So we have a single monomial term multiplied with a binomial, so to speak. So 7i is multiplied with the 2 minus 9i. All we're going to do is go ahead and multiply that on in. So I have a 7i times 2, that's going to give us 14i. 7 times a minus 9 would give us a minus 63. I times I would give us an I squared. Now I'm not finished because it said you had to have the real part added with the imaginary unit. Remember, we're looking for an a plus bi. Well, I have an I squared. Well, what do we say I squared was equivalent to? I squared is equivalent to a -1. So if I have a negative 63 that's now multiplying with a -1, that's going to give us a positive 63. That means we're going to have a 14i that was added with 63. The correct way would be the 63 in the front, add that with the 14i in the backside. So that's what your answer would be for that one. Now in part B, when we're multiplying, they said we're going to treat it very similar to any binomials in that sense, our polynomial expressions, which means that we need to do a little bit of FOILing. So I'm going to take 5 times 6, which is going to give us 30. 5 times our minus 7i, that's going to give us a minus 35i. Inside terms, positive 24i. Last terms are going to give us a minus. We'd have a 28i squared. And just like what we did with our I squared before, as soon as we see an I squared, we have to remember that that's a -1. And if we have a -28 and a -1, that's going to give us a positive 28. And if we combine our real unit, we have real unit 30 added with 28, which is going to give us a 58. And then our imaginary units, a negative 35i and a positive 24i. That's going to end up leaving us with a negative 11i, so minus 11i. So looking at the conjugate of a complex number, we talked about conjugates in our prerequisite skills, so continuing on with the conjugate of a complex number, says for the complex number a plus bi, we define its complex conjugate to be a minus bi. Remember, a conjugate is just multiplying by exactly the same setup, but changing the sign. So if it's a plus sign, we use a minus sign. If it was a minus, we use a plus. It says that the product of a complex number and its conjugate is a real number. So they went through and showed you the example. If you have a plus bi and you multiply with a minus bi, and you go about foiling it out. A times a times the minus bi times a, bi times the minus bi. So they go through the process of figuring out that what happens in the end is if we have our conjugate, typically the idea is that those middle terms should end up canceling out. We have one as a plus and one as a minus. The other thing that happens when we have that I squared was equal to a -1, which now ends up that -1 and that minus with that b squared now gives us just an a squared plus a b squared. And notice we have no more imaginary unit. We have just a real number because they're just going to be regular numbers. So let's look at an example. Actually, in a moment. It says complex number division. It says the goal of a complex number division is to obtain a real number in the denominator. Denominators have always been the thing that messes us up in terms of our domain, right? We couldn't have a 0 as a denominator. Anytime that we have our imaginary unit, we cannot have an imaginary unit in the denominator, just like we couldn't have a square root in a denominator. So it says that we multiply the numerator and the denominator of a complex number quotient by the conjugate of the denominator to obtain this real number. So now let's try an example. It tells us to use complex conjugates to divide our complex numbers. So divide and express the result in standard form. So we have a 5 plus 4i that's being divided by a 4 minus I. So in order to undo the imaginary unit in the denominator, we need to multiply it by the conjugate. So if we have a 4 minus I, we need to multiply by a 4 plus I. And whatever I do to the bottom, I also have to do to the top. In order to multiply by a value, that value had to be a 1. So we have to do a little foiling on top and a little foiling on the bottom. Let's see what we got. The top 5 times 4, 20. Outside would give us 5i. Inside would end up giving us a 16i. And our last terms are going to give us a 4i squared. We'll go back and simplify that out in just a moment. On the bottom, since they are conjugates, we know the inside-outside term is going to end up canceling out. So that means I just need to multiply 4 times 4, which is going to give us a 16. And we have a minus I times a plus I, so that's that minus I squared. If you don't trust me on that one, you're more than welcome to go ahead and do the whole inside-outside terms. But you're going to have a plus 4i and a minus 4i, which cancels. So let's simplify this down a bit. So on the top, we have an I squared. That means that that's a -1, which means that this whole piece here is really a -4. So if we have 20 and a -4, that's going to end up giving us a 16. Plus we have 5i and 16i. That's going to give us, we got what, 21i? Let's see on the bottom. We have this I squared, that's a -1. So if we're subtracting a -1, 16 minus a -1 is 16 plus 1, which is 17. Now they want it in standard form, which means that they want the real portion added with the imaginary. That means we need to break up that fraction into 2 pieces. That means we're going to have a 16 over 17. That's going to add with a 21 over 17 with the imaginary unit behind it. So all you're doing is breaking that into those 2 different separate pieces. So the next piece talks about the principal square root of a negative number. It says for any positive real number b, the principal square root of the negative number, or negative b, is defined by, if I have a square root of negative b, what they're going to do is they're going to break this into a square root of -1 times a square root of b. And they already told us the square root of -1 is that imaginary unit I. That's going to be multiplied with that square root of b. That's where this piece comes from. So anytime you see a negative on the inside of a square root, it's going to give you that imaginary I on the outside. So let's try some. Perform the indicated operations and write the result in standard form. So we have a square root of -27 that's added with the square root of -48. So we're going to take -27 and we're going to break it up. That means I have a square root of -1, which is going to give us that imaginary unit I. And then 27, perfect square factors of 27, that would be 9 times 3. So the negative 1 is going to give us an I. The square root of 9 is going to give us a 3. And root 3 is going to be stuck inside. That means we would have a 3I square root of 3. And then we're going to add with that. Let's break down that negative 48. Well, again, that negative is going to give us a square root of negative 1. 48, perfect square factors. That would be a 16 times 3. So that means we have the imaginary unit, we have a 4, and we have a square root of 3. So that means we have 4I root 3. Now, if I have 3I root 3 plus a 4I root 3, I have a 3 plus a 4, which is going to give us a 7I root 3 as that final answer. In part B, we have a negative 2 plus square root of negative 3 that's being squared. Now, remember they said treat it just like we did with our polynomials. When in doubt, FOIL it out. Some of you are still making the mistake when you're taking a binomial and squaring it, you're missing that middle term. So make sure if you need to, just write it out side by side. Negative 2 plus we have root negative 3 multiplied by negative 2 plus root negative 3. And if I do my first, outer, inner, last, let's see what we got. Negative 2 times negative 2, that's going to give us a positive 4. Outside terms is going to give us a minus 2 root negative 3. Inside terms is going to give us a minus 2 root negative 3. And our last terms, if I take a square root of negative 3 times the square root of negative 3, the square roots are going to cancel. That's just going to give us a minus 3. So let's see what we got. We still got those negatives inside those square roots. All right, let's see. Whole number unit, or the real unit, I have a positive 4 and I have a minus 3. That's going to give us a 1. If I simplify this middle stuff here, we have minus 2 and a minus 2. That's a minus 4. And a root negative 3. To get that negative out, that's going to give us a minus 4I root 3. And that's going to be our final answer for that one. Now, what happens when we have some quadratic equations with our complex imaginary solutions? It says a quadratic equation can be expressed in the general form ax squared plus bx plus c is equal to 0 and solved using the quadratic formula. Some of you kind of had some minor brain farts back in the prerequisite skills. Please make sure you're familiar with the quadratic formula at this point. X is equal to negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Now, another piece that some of us kind of missed along the way, what's inside of that square root is called the discriminant, or b squared minus 4ac. It says if the discriminant is negative, a quadratic equation has no real solutions. We talked about that when we talked about the discriminant. What happens with our quadratic equations with negative discriminants, we're going to have two solutions that are complex conjugates. Now remember, our conjugates means one thing is going to be a plus and one thing's going to be a minus, but they're going to be some sort of complex conjugate. We're going to have some sort of imaginary unit involved because it was a negative value in a square root. So let's try one. It says to solve using the quadratic formula, we have our x squared minus 2x plus 2 is equal to 0. And so it's always helpful to go ahead and identify the a, b, and c value. If you remember, we would have had our ax squared plus bx plus c is equal to 0. That means our a value is going to equal the number in front of the x squared, which is 1. Our b value is the number in front of the plain x, which is a minus 2 or a negative 2. And our c value is the number that's all by itself. It's a positive 2. So then we just plug in for a, b, and c and simplify it down. So negative b, or the opposite of b, well, if b is a negative 2, that means that we're going to have a positive 2 plus or minus the square root of b squared. Well, my b value is a negative 2. Are you okay if we just negative 2 squared gives us a positive 4? That's going to be minus 4 times an a value of 1 times a c value of 2. If you don't like that, that was a negative 2 that was squared. And then that's all going to be over top of 2 times our a value of 1. And we'll simplify that down then. So that means we have a 2 plus or minus the square root of, let's see what we have. So that negative 2 squared, that was a positive 4. Minus 4 times 1 times 2. 4 times 1 times 2 is 8. So 4 minus 8, that's going to give us a negative 4 stuck on the inside there. And then we're dividing by 2 times 1, which gives us 2. Well, if I have a square root of a negative 4, let's see if we can simplify that down a little bit more. That's going to give us 2 plus or minus. Well, I have that negative, which is going to give us that imaginary unit. And the square root of 4 gives us 2. So that's going to be a 2i. And then that's being divided by 2. And simplified down, that's really going to be a 1 plus or minus I, which means that we end up with 1 plus I and 1 minus I. And those are our complex conjugate answers that they were telling us that we would end up having. One is a plus and one's a minus.